Alrighty, so here is our video explaining mission 3. This is our last mission for CS4404, and it deals with covert channels. So I'll give a quick rundown of the infrastructure we have for our attack right now. We're using 5 machines. Over here on the right side, these 3 machines are on subnet number 1, and this is supposed to represent the external network. The machine in the middle, this is our router, and it connects subnet 1 and 2, so it's on both of them. And then on the left side here, these 3 machines are on subnet number 2, and this is supposed to represent our internal network. So to give a breakdown of the machines, the first machine here on the top right, machine number 1, this is our CNC machine, our command and control machine. So it's the one that uses covert channels to communicate with the bot that's on the internal network, which is over here. It sends data, well, it uses 2 attacks. It sends data to the bot using HTTP headers, just malforming some metadata, and it receives data from the bot through DNS queries that are basically, I'll show you right now. So we're assuming that the user has a text file called passwords.txt on their computer, and we're taking the password and we're appending it to a DNS query for the domain dot or whatever .com. So that's how it receives data. It just takes the DNS query, strips off the host name, saves it to a text file called passwords.txt on this machine, which I'm just going to delete this so we can check on it later. Yeah, it just splits it and it appends it to passwords.txt. So I'm going to close this now. So that's what this machine does. We'll demonstrate the attacks in just a second here. The second machine here, this is the one that we're using to test for false positives. So it's supposed to be another machine on the open internet, and it simply runs a node server, so it sends HTTP data. And the point of this machine is to check whether, when we have our defense up on machine 3, whether or not it's going to stop packets that don't have the certain criteria we're checking for set, so they don't get blocked, obviously. So we'll demonstrate the HTTP attack in just a moment here. And for the defense for that attack, so we simply modify on the node server modifies the date field in the response, and it changes the changes the word GMT, which is a time zone, to GNT, and it's something that a lot of people would probably miss, a lot of network administrators, at least we're hoping, but there are plenty of other routes that you can take, and we're just checking for this one field here, but technically we can develop this program out to check for every single field and then just normalize every single header, but for the purpose of this project we figured that wouldn't be necessary considering it's a network security course and we're just trying to demonstrate like the most simple and straightforward way of carrying out the attack, but obviously it could get more complicated. We have Wireshark running, so I'm just going to close this file here. And then I did not explain the bot yet, but in essence it's the opposite of the CNC machine. It receives information through the malformed header field in the HTTP packet, and then it sends back data over DNS. So, oh, that is not the right. I have all of the Python scripts in this folder here, but this one uses, yeah. So this one uses DNS queries. So it takes a line from the password.txt file and then appends it to .whatever.com, it's our URL, and then it opens up command shell and then sends a dig for this DNS server with the password appended to this domain. And then for HTTP, well, not the right file, infected machine. So here it's just reading the date field and then check and see if the time zone is GMT, and then it checks the time. If the time is set to one of two, predefined times that we agreed on, which is one is here for DDoS, one is here for overflow. You can develop this out as much as you want to, but we went for something nice and simple, and it waits 10 seconds before sending, between sending queries. You can extend that time to be as long as you want, longer, more covert. And then lastly, machine 5 here. So this is our our testing machine. It sends out DNS queries and sends out HTTP queries, and then we just make sure that none of those get blocked. But the ones that come from this machine or this machine do get blocked. So I'll demonstrate the HTTP attack right now. I have to run the server on this machine, which it doesn't matter what it sends back, as long as it sends back a 200, which this machine checks for. That's all we really want. And then we have to run this server as well. So I believe both are running. And now we have to run the defense script, which, yeah, I already showed that. So that's an IPS. So we're going to run it in default mode. So it's not running as an IPS, intrusion prevention system, which would drop the packets. But what we'll do here is we'll start the test here. So it's getting 200 responses from this server, and then I'll run this Python script, and as you could tell, like, the router detects that there's malicious header data, but it still allows the attack to go through, or the packet to go through. So let me stop everything here. So now let's do all that, but run this code in IPS mode. So it will drop packets that meet that criteria. So now when we run this to create HTTP noise, nothing's happening, but when we run this machine, it's dropping the packets. So before, whereas it was printing DDoS attack, it's not printing anymore, and it's going a lot quicker than 10 seconds, as was the interval, because it's retransmitting a lot of the packets. Alright, so that is our HTTP defense and attack. Now let's switch over to DNS. So I'm just going to run this here. cnc.py, right, it takes the host name, appends it to password.txt, and then we're going to run machine 5 DNS here. This will get extremely noisy on the network. So let's run we're going to run IPS. So it's not running in IPS mode, so it's just listening for data, and here we're going to run machine 4.py. So we're just sending, oh wait, that's correct. So we're just sending a whole lot of DNS queries, and this machine is picking them up, and the ones for whatever.com, it appends to passwords.txt. So we got all, if I can count right, 10 of them. So now let's rerun the attack, but in IPS mode on this machine. So we could just leave that running. So now I will specify to run an IPS. So yeah, now we'll drop packets. The way we have this defense set up is that we have a threshold 8. If it detects 8 different DNS queries to the same domain, then it's just going to drop the packet. This could be as fine-tuned as possible, but usually a site's not going to have 8 different host names, or, well, in our purpose, we're just assuming it's not going to have 8 host names, but I mean, you can change that to whatever you would like. So we're running the attack now, and as you can see, it's picking them up, but here it stops because it detects that there are too many DNS queries for that same domain. So yeah, and you can see that it did not get